All right, welcome everyone. It's now 5, so I will start. There's probably more people coming in, but since we're punctual, I will start now. Yeah, so I'm excited to see many participants, and I hope that you're ready to get inspired in the middle of the week with the new Dev.Wednesday talk. I would like to start to introduce myself. So I'm Simona. I work at Swisscom since last August, and I'm a step-in employer branding and responsible for the event management at Swisscom. And I co-organized the Dev.Wednesday with my colleague, who unfortunately cannot be here today. As a quick information before we get started, so the session will be recorded and uploaded on YouTube. Also, I will be moderating the questions. And if you have any questions throughout the presentation, please just ask them in the chat. And I will then ask the questions right away in the presentation to Toni, our speaker today, or I will ask them at the end. So it depends a bit. But yeah, so we will have time throughout the presentation and also at the end for a Q&A, where we will have some time planned for that. So let's get started. Today we will learn more about Kubernetes Policy Management, and I would like to warmly welcome our speaker, Toni. He is a DevOps engineer at Swisscom and works at Swisscom since 2018. And in his talk, Toni will show you how to integrate Open Policy Agent into your development lifecycle to ensure your container stays safe and sound. So I would like to now hand over to you, Toni.
Thank you, Simona, and hello, everybody. Thank you for your time, and I hope that I can teach you something about this interesting topic that we have today. Today we're going to talk about policy management for Kubernetes using the Open Policy Agent and especially its Gatekeeper component. We'll start with some theory about OPA, how OPA translates or operates into in Kubernetes, how you can use it in your CI pipeline, and I'd finish today with a live demo, so wish me luck. Motivation. Why would one want rules anyway? Developers like freedom, and rules are just in a way of creativity and speed. For one, systems like Kubernetes are insanely powerful, but at the same time can get very complex. Not everybody is a rockstar developer, and even your apprentices need some common denominators, some guardrails. And at the end of the day, too much freedom can be complicated. Furthermore, especially in large corporations like Swisscom, you have hundreds of different regulations, you have laws, you have governance. For example, FINMA regulations are really popular in Swisscom. You have ISO standards, you have security standards, and all of these need to be followed. It's really hard for the developer to follow all of these without having some system assisting you in the process. All these regulations also periodically get audited by external companies. So it helps if you have a standardized system where you can just pull your data from and see if you're compliant or not. What security guys will tell you is, what security guys would profit most is avoiding risks before they actually deployed. It's much easier to avoid the risk before deployment than checking these things when your software is already running in production. Now, at the same time, you don't want to annoy your developers. Developers are really peculiar creatures. You want to keep them agile, you want to keep them autonomous, And it's not just about the developer. At the end of the day, everybody in the company needs to be happy. So you want to make money quick, deliver features while keeping security happy, and your operations teams shouldn't have too much to worry about either. If you look at these both columns, it sounds like a bit too good to be true to establish all of these things at the same time. But with OPA, we are trying to get there. So what is OPA? OPA stands for Open Policy Agent, which is a general purpose policy framework where you basically can define your policies as code. It comes with its own declarative Rego language, and at the end of the day, you just define rules that are applied to data. OPA is open source and has been donated to the Cloud Native Computing Foundations in 2018, meaning that there is no single company owning it. The community has ownership and anybody can participate in it. Some examples of rules that you can define with OPA. You can, for example, say every namespace in Kubernetes must have an owner, or you can define any object in Kubernetes needs to have some kind of defined label. And an alternative would be you want only user accounts to be able to SSH into Linux VMs. No root SSH for your developers. And you can deny privileged containers on Kubernetes too. Basically, you can use OPA on your whole stack from the bottom to the top. This is a little example of how that would look like. On the bottom left, you see OPA used with service meshes as authentication module for your software. The top left is Kubernetes with Gatekeeper that we're inspecting in this talk. Top right is more infrastructure layer with SSH and Linux. And on the top left, you can actually define OPA policies for your infrastructure provisioning frameworks like Terraform too. As I've already said, is that we're mainly concentrating on the Kubernetes part of OPA. But still keep in mind that I think it's beautiful that you can use the same framework through your whole stack. So this makes defining policies really standardized and elegant. What I've heard quite a few times in the past was what's OPA and what's Gatekeeper. So OPA, meaning Open Policy Agent, is the general policy agent, the general policy framework. It's the engine of which actually takes the data and evaluates your rules against it. Gatekeeper, on the other hand, is the specific implementation for Kubernetes. So if you want to use OPA on Kubernetes, you would talk about Gatekeeper. What does Gatekeeper consist of? Gatekeeper consists of so-called Kubernetes CRDs, which are custom resource definitions, and you can, if you're not familiar with Kubernetes, these are just Kubernetes objects that you define on your own. And in the case of Gatekeeper, they're called constraint templates and constraints. Constraint templates are the actual rules, and constraints enable these rules on a set of objects that you tell it to. Furthermore, it's based, Gatekeeper uses admission control, the Kubernetes admission control, to evaluate new objects. Any request that goes to Kubernetes goes through these gates and gets evaluated. I'll go into a bit more detail on a later slide. The third component is the actual OPA engine. OPA itself gets deployed to your Kubernetes cluster by default. So you deploy it to by default to your Gatekeeper system namespace. It receives JSON objects from the webhook in number 2, and evaluates that one against the constraints from number 1. Furthermore, Gatekeeper offers an audit loop, which is a little pod that runs periodically and validates all existing objects in your Kubernetes cluster. So if you have different deployments, pods, containers, and so on, these get evaluated against all rules that you've defined in number 1. It doesn't necessarily do anything with them, but so it doesn't remove them if they violate the rules, but it will tell you that there is a problem. To number 1, this is an example of a constraint template, so the custom resource definition. It might look a bit overwhelming, but it's actually not overly complex. This is the Rego language of OPA. In this example, we're talking about so we're trying to prevent people from deploying privileged containers, which you define here. You say object spec containers. So we're looking at containers and init containers, and we're checking for security context.privileged. If this is true, deny the container and give a message saying privileged container is not allowed. We'll see this later in the demo. So this is the actual rule that you define, and in the constraint itself, you define to which API groups and which Kubernetes objects you want to apply this to get applied. So in this example, we want all API groups, and we are only interested in pods. Also interesting is that this is also the place where you exclude or whitelist namespaces where you don't want this to be true. So we're saying that in the kube system namespace, we know that there are some privileged containers, and as some people might know, these are Kubernetes containers, and they're allowed to run as root. To the Kubernetes admission control, any request that goes to Kubernetes starts on the top left, goes through authentication, authorization. If you submit an object to Kubernetes, like let's say a pod, it also goes through admission control. The first one is mutating admission control, which takes your object and might add some values. An example for that would be adding resource limits to your pod if they don't exist. After that, it goes through object validation, through validation admission. Validation admission is nothing else than a gate telling you the object is allowed in Kubernetes or not. And if all is fine, it finally gets persisted to etcd. So where OPA comes in place is on both sides, on the mutating admission and on side of the validating admission. The validating admission is the main use case of OPA. So usually people want to say, I don't want root containers, so please prevent them being deployed. But you could also define any kind of logic saying, okay, if my developers aren't following best practices, I want to add these best practices automatically to their deployments if not existing. This you would do with the validating webhook on the with the mutating webhook on the right, sorry, on the left, sorry. So how would you go about rolling out Gatekeeper in a company? First, you install Gatekeeper and a defined set of policies. An interesting feature that you should use initially is Gatekeeper's dry run feature, which does nothing else than it doesn't prevent anything from being deployed to the cluster, but it logs everything. So you can see what would happen if I would enable my policy and count the violations of it. These violations you would observe over time on your existing workload and optimally try to fix as many as possible before actually enforcing the policy, which is nothing else than removing the dry run from from your constraint. By doing it like this, you can avoid friction with your developers. Let's say if security would just go on and force enable all of their policies, developers basically couldn't work anymore because nothing would be able to be deployed on clusters anymore. After installing policies in your cluster, you have three main ways of evaluating what's going on. By default, you have the audit component, which periodically inspects all Kubernetes objects. This can be quite resource intensive if you have hundreds and thousands of objects like pods in your cluster. It goes through it gets all objects existing in Kubernetes from the API server and validates them against the install constraints. You can inspect after that every constraint and check the violation count and what exactly is not good at the moment. This gets quite messy if you're talking about dozens of rules and policies. And for that, there is an open source UI called OPA Policy Manager. It's an open source UI that you can deploy separately to your cluster. And I advise using that if you're talking about the large number of constraints and objects. Last but not least, OPA Gatekeeper has the ability to send its logs to any kind of backend like Elasticsearch, Splunk, and so on, where you can put additional logic on it. And it obviously, as most cloud native tools, has an option to export its metrics to Prometheus. So now we've talked about Gatekeeper on Kubernetes, but if you think about it, Gatekeeper only prevents objects from being deployed in the cluster, which is really late in your development lifecycle. Let's quickly summarize how a typical Kubernetes development workflow might look like. First, you have some coders that develop your application. This means it's the actual coding, and you define some Docker images and Kubernetes manifests. After that gets committed to Git, the code gets built, tested, and a bunch of CI magic is being applied onto it. If all is fine, the image gets shipped to an image registry, and you increment the version tag of your deployment. Finally, you will be able to deploy stuff to your cluster using tools like continuous delivery or nowadays GitOps. So up till now, we've checked this part. So we used Gatekeeper to prevent malicious objects being deployed to your cluster. Additionally to that, there is another tool from OPA called Konftest, where you can shift this logic left to your CI pipeline. And I'd like to show you how this works. OPA Konftest is an OPA engine that works for any kind of config file. You can use Kubernetes, YAMLs, Terraform, configurations, CI/CD pipeline, any kind of files you like. There is one little issue. Konftest uses pure Rego code as input and can't read Gatekeeper templates. So it can't read your constraint templates directly. And for this, there is a little open source tool called Konstraint. It is a CLI that can generate Gatekeeper YAMLs for Kubernetes from pure Rego. this enables you to have one single source of truth. You don't need to write Rego code directly in your YAML and one for conf test. And it's also open source and has a really nice list of example Rego policies that you can use to inspire yourself. I'll quickly show you the examples in the demo. So it's demo time. Wish me luck. I'll try to switch to my terminal. Simona, can you see my terminal?
Yes, I can.
Thank you. What we're going to do in the demo is I'm going to show you how easy it is to install Gatekeeper. I will enable a policy that prevents privileged containers to be deployed, and then we'll try to deploy a privileged container anyway. So bear with me. I'm on a Kubernetes cluster here, which is a Swisscom cluster. Swisscom has an offering of certified Kubernetes clusters based on VMware Tanzu, formerly known as PKS. So this is a Swisscom cluster where in this particular example, I have a Cloud Foundry running on Kubernetes. On this cluster, we will install Gatekeeper and see if we can prevent privileged pods from being deployed. I'm in my Gatekeeper directory, and this is the Gatekeeper YAML. And installing Gatekeeper is as easy as just applying its YAML file. And you see, these are all the pods that Gatekeeper consists of. I just showed all the objects in the Gatekeeper system namespace. Now we have Gatekeeper, but we also need some policies that we want to apply. I've switched my tmux lane, and now I'm in my constraint example directory. Let's start with generating the constraints. So I'm using constraints to create all YAML files from the Rego base source in the example directory. Now you can see this is the pure Rego that conf test could use to validate against YAMLs, and constraint has generated a constraint YAML and a constraint template YAML for me.
Toni, there's a question.
Yes.
May I ask you? Okay, so do you need to configure this Gatekeeper YAML file, or does it work out of the box?
By default, it works pretty much out of the box. You can tweak a few knobs if you want, like setting excluding namespaces on a global scale, but by default, it really just works out of the box.
Cool, thank you.
I hope this answers the question, and if not, I'll be happy to answer more questions at the end. So, as I said, Konstraint generated me these YAML files, which I now can actually apply to my cluster too. Now you see I have a container denied privilege constraint in my cluster. Let's change our namespace. here is a little example of an Nginx pod running with this security context privilege true. So this means this pod is actually running in privilege mode. If everything went well, let's see, in the namespace we don't have anything right now, and I will try to see what happens if I apply this. Ah, shit. It doesn't let me deploy it. So Gatekeeper is actually preventing me from installing something that I'm not allowed to. So now let's do some debugging. What could I change here? Maybe I need to change privilege to false. Ah. And now my container is up. Let's see if it actually comes up. Yeah, container is running. This was just a really quick example. You can do any rule you want. I would really recommend you using the example policies that you can find from Konstraint. This is the GitHub of Konstraint, and here you can see the list of different policies that they have prepared. Most of them are really best practices and make a lot of sense to use them in your Kubernetes or OpenShift clusters by default. You can go to...
Toni, there's another question.
Yes, please.
Can you quickly mute yourself? Because I think I hear my echo. Okay. So the question is, what happens if you apply a new policy on a cluster, but the existing objects are already violating the new policy?
Yes, so by default, nothing happens. So Gatekeeper is not going to, Gatekeeper is not going to delete any kind of pods by default. What would happen is that if your pod gets rescheduled, it will go through admission control again, and then it might get denied. By default, Gatekeeper only goes, puts the violation count 1 up, and it would prevent you from redeploying the pod or the object. There was actually a thread on the Gatekeeper website, and they're thinking about offering this as a future option, so that you have a more intrusive way of dropping everything that violates your constraints. But by default, it doesn't do it. To end my presentation, I want to quickly talk about 2 things. PSPs, so-called pod security policies of Kubernetes, will be deprecated with Kubernetes 1.20 and dropped with Kubernetes 1.25, I think. And it looks like OPA Gatekeeper is the perfect replacement for it. The community basically has already accepted it. From a Swisscom perspective, we're also thinking about, so what I've just shown you is really easy for one cluster, but it gets really hard if you want to do it on a company level. So you have security defining global rules, you have teams defining their own rules, and you have developers that have their own needs and sometimes need to override the higher policies. This gets quite hard to do with just a Git repository. And Styra, the parent company that had created OPA in the first place, offer a software as a service or an on-prem solution that facilitates that. And we're actually just now talking to them. And this looks like a really elegant solution to manage your OPA policies on a company level. And with this, I'd like to conclude. In my opinion, OPA is great and Gatekeeper is really usable. And at the end of the day, anybody using Kubernetes or OpenShift should have it. If you're afraid of breaking stuff, start with some basic policies, put them into dry run and see how this evolves. In our case, our developers were actually really happy about it, as it makes their life easier, not harder. It's much nicer to know that you're not following rules automatically than having a security guy shout at you 5 months later when you're already in production. My personal opinion, I would use conf-test and constraint from the start, because it's really cumbersome to write rego twice. This was something that I hadn't known in the start, so I'd like to give you this heads up. And with this, I'd like to hand back to Simona.
Thank you. Can you mute yourself quickly because of the echo? Right, so there's actually a few questions from the audience that I would like to pose to you. I will publish it, just one moment. So yeah, the first one is, what happens with running pods if a policy gets changed? Is there any callback, notification, webhook if a running pod does not meet the policy rules anymore?
So a running pod, you couldn't change a running pod while it's running, so it wouldn't allow you to change it, because changing pods goes through admission control. So I'm not 100% sure if the question is more about changing the pod or changing the policy. In both cases, this is so if you change the policy, you could gather the information from the running objects on the violation count or with the logs or the metrics. And the pod you shouldn't be able to change as if it violates the new policy, or if it gets redeployed, then yeah, you might run into trouble. So this is actually I think it's a really good question, because the evolution of policies is not trivial in my opinion. So you start with a container privilege deny v1, and then add v1.1 as a dry run. You see what happens with that one, enforce the 1.1 at some point, and drop the old one at a later stage. That's how I would.
All right, thank you, Toni. We have another question. Can we combine multiple policy configs, for example, basic for all systems plus custom, in a multiple file? Is there a plan to have a vanilla policy for Swisscom, for example, SBD, with no root access as showed in demo?
Yes, so Rego offers, it's not a real programming language, it's a DSL, but it still offers imports. So you could have a package, let's say GSE. So on a technical level, it's certainly possible. On an organizational level, we're currently hoping that we'll go with this Styra solution, which would make it easier. There you have a clearly defined hierarchy of policies. Using native OPA, this might be a bit more complicated, I guess.
Thank you, Toni. There is another question. Would you recommend OPA instead of Kyverno? I don't know if I pronounce it right.
It's a good question. We've looked at Kyverno too. I actually don't know how to pronounce it either. We had the feeling that the community support is bigger and that it's supported a bit more but there's different opinions, and I think this will have to show itself with time. So there's no clear answer.
Thank you. We have some more questions. I hope you're ready, Toni. Can you run a scan of non-compliant objects in the cluster after deploying the gatekeeper?
Sorry, how was that?
Can you run a scan of non-compliant objects in the cluster after deploying the gatekeeper?
Yes. 1 second. Yes. I'll quickly scan of non-compliant objects. So basically this is, so I get the question now. Basically this is what the audit loop does by default. So Gatekeeper itself requests all objects from Kubernetes, which is actually like a scan. So by default, every 6 minutes or 305 minutes, the Gatekeeper pods, so there's a Gatekeeper audit pod in Gatekeeper system, requests all objects from Kubernetes and scans these for violations. And if it finds violations against the rules, it increments the violation count on each constraint. So let's take the example that with the example that I did in the demo. You enable a constraint forbidding privileged pods or containers. As soon as I enable this policy, with the next audit run, Gatekeeper will get all objects from Kubernetes, and every pod, every container which is privileged will increment the count on this constraint by 1. They won't get dropped, or they won't get deleted or anything. They won't, but you will see it there.
Thank you very much, Toni. Another question: how do you apply the policies only to specific group? For example, company's AD group. How does it integrate with Active Directory?
That's a really advanced question already. This goes a bit into the question of using the open source or the additional vendor proprietary software. With native OPA, so what you can do is OPA can use any kind of backends in its engine. So you could tell OPA to actually, so going back to the Kubernetes example, you have an object. A Kubernetes object is nothing else than a JSON object. This gets sent to OPA. Now you could define in your Rego code that you want to go to Active Directory to fetch some kind of information from there. So role groups or organizational unit and so on. And in the Rego code, you can act on this in any way you want. Active, yeah. I think this is, for example, company's AD group. Or another example would be you define in Rego, so in the OPA programming language, what means if I have the AD group, let's say inidos. So does this give you this? Then you can define what kind of rights are associated with them.
Thank you, Toni. There is another comment. It's not a question, but it's actually a compliment. So someone says, "Thank you, Toni. This was a really great overview and demo. Well done." And it happens. So I don't think there's another question. I will give you some more seconds if there's another question coming in. Otherwise, we will continue, and I will take over. Yes, I think there is no other questions. All right, so Thank you very much, Toni, for your interesting presentation. As you said, I will now take over. So I would also like you to highlight, I need to unmute you, Toni, otherwise I hear my echo. Perfect, thank you. Yeah, so if you would like to check out the current vacancies, please visit the corporate jobs and career website. And there you will find the current vacancies that we have. And we would also like to highlight some of the current open vacancies within the area of cloud. So you can just scan the codes of the respective vacancies that you see on the screen to get directly to the job ads. And I would also like to highlight that there are many more open vacancies within DevOps, and you can just go to the website that I mentioned before and set a filter, and then you can search for the jobs you're interested in. And if there's any questions regarding the above mentioned vacancies or general HR related questions, you can just connect with Jelena. I hope you now see the screen with the QR code. She is our recruiter, who will be happy to answer your questions, and you can get connected with her on LinkedIn. And finally, if you would like to get access to the slides that Toni shared with you today in a PDF format, you can just scan the QR code here, download the slide set, and you can also watch the recording on YouTube that I have mentioned before. You can just type in YouTube Swisscom B2B, and then you will find today's recording in the webinar playlist, and where we will upload this recording here. And yes, feedback, right? Thank you. Also, we created a very short feedback form, so please use this link or the QR code again to give us feedback as well to our today's event. We really appreciate your feedback and inputs, and that would be really great if you could do that. I will quickly check if there's another question. So there's actually another comment to you, Toni. Again, thanks a lot for this cool intro and demo, Toni. And yeah, there's no other questions from your part. So I would actually like to thank you, everyone who participated, for your participation in today's online meetup. I hope you really got inspired today and that you enjoyed taking part at the online Dev.Wednesday. We obviously hope that we can soon do a Dev.Wednesday again in a physical format so that we can meet you in person. Yeah, let's hope very soon that we can do that again. And also thank you, Toni, for your great presentation. And I wish everyone a really nice evening.